Welcome to another ABC University training session. In this session, we are continuing on with the multiplex training as this is part 2, testing. If you have not already viewed multiplex training part 1, Introduction to Multiplexing, please stop now and revisit multiplex training part 1, Introduction. The signal on the CAN L or CAN low is called the mirror signal of the CAN high. This double signal allows for fault detection on data exchanges and provides a high degree of protection against interference. Let's go over how to test the CAN bus. With the vehicle ignition on, there should be a voltage of more than 2.6 volts on CAN high and less than 2.4 volts on CAN low. An interrupted, inverted, or shorted CAN bus can be traced by measuring the voltage. Again, example would be CAN high, 2.6 volts or above. Low would be 2.4 volts or below. Voltage should never be the same. Now, with vehicle ignition off, there should be a resistance of 60 ohms between the two wires on the CAN bus. In this slide, we're going to go over how to use your engine diagnostics plug to test the CAN bus line. To start, check between pins C and D for resistance. Now again, when you're checking for resistance, the coach must be completely powered down. Your resistance should be 60 ohms. If I have anything else besides 60, I have a problem inside the system. If I am reading 120 ohms, that tells me that I have a termination resistor that is out of the system. If I was to read 40 ohms, that tells me that I have an extra termination resistor tied into the system. Next, check between pins C and E and D and E for resistance. This should be open. If my actually show resistance here, there's a possibility I could have a termination resistor pinned incorrectly, showing me resistance on the wrong line. Next, check between pins C and E for voltage. In order for you to check voltage, you'd have to have the coach on at this point. You should be above 2.6 volts, because that would be your CAN high. Next, check between pins D and E for voltage. It should be under 2.4 volts for your CAN low. And what is the resistance of a termination resistor? 120 ohms. Your next question you may ask me is, if my termination resistor is 120 ohms, why am I getting 60 ohms when I check between C and D? And this is how you come up with it. If I have two termination resistors of 120 ohms, I take that 2 and I divide it by 120, which gives me my answer of 60 ohms. So when I have two termination resistors tied into the system of the same value, I divide it by that number of resistors, and that's what my value should be. In this slide, we show your J1939 3-pin Deutsch connectors. To the left, you show your single connector or your termination resistor. Pay attention to how it is set up. If you look at the top of your termination resistor, you'll see the prong for where it actually clips in to the plug. On the top, that's where you would have A and B. A is my J1939 high. Pin B is my J1939 low. Pin C would be my shielded cable. Between A and B, I should have a 120 ohm resistor when the system is unplugged or taken out of the system. In the next few slides, I'm going to show you just examples of checking your CAN line for diagnostic points. Here, if I check the CAN line low, ignition must be on and connector plugged in, I should have at 2.4 volts or below. And in this slide, checking CAN line high, again, ignition must be on and connector plugged in, I should be at 2.6 volts or above. And if I was to check here for checking termination resistor with ignition off and the system was unplugged, I should be at 120 ohms, because I'm only checking one side of the system, which I would only have one resistor. And here, if I was checking termination resistor with ignition off and the system plugged in, I should have 60 ohms, because I'm picking up both termination resistors. Static inputs can be powered in different ways. You have a positive or 24 volts and ground. Most inputs are positive or 24 volts. Note, you measure a voltage of about half the onboard voltage at the input if the switch was open. In this slide, we're going to show you an example of what we were talking about. If you look at the diagram here to the left, if you notice, on the side where I send power to the switch, I have 24 volts. The switch is open, so on the other side of that switch, I will have half my onboard voltage, which is 12 volts. The switch is closed, line will have 24 volts. When switch is open, one side will have 24, input side will have 12 volts. Analog inputs. There are 6 analog inputs on each node. You can connect a variable resistance of between 0 and 500 ohms to these inputs for further analog processing. Examples would be air pressure gauges, HVAC sensors, and brake wear sensors. Outputs on nodes. The outputs are divided into the following types. You have high switching and low switching. How do the electronics detect a short circuit at the output? A short circuit at a node output is detected via internal feedback. And how do the electronics detect an overload at the output? An overload at a node output is detected by the thermal cutouts of the final stages. Extremely high impedance at a node output. An output connected to a load with very high impedance, example an LED, behaves like a non-loaded or interrupted output. Thus, the voltage at the node output can amount to several volts. Very high impedance loads cannot be checked for interruption. Residual voltage can cause side effects that can only be avoided by installing a resistor in parallel with the load. The resistor introduces an extra load, making the voltage at that output drop. In this slide, we're going to show you an example of numbering of inputs and outputs. So example would be node 4, A18. 4 is my node number, A is the connector into the node, and 18 is my pin number on the connector. And the description would be, this is for the rear light left-hand side. All node outputs are protected against a short circuit and overloads. Nevertheless, each output has a maximum output current rating. There are outputs of 1 amp, 3 amp, 5 amp, and 10 amp. Next, we have groups. The outputs are divided into 5 groups. The total load on all outputs in a group must not exceed 15 amps. The groups are indicated with the letter G, followed by a group number. For example, G3. In this slide, we give you an example of your node current disturbance. If you look to the right, you will notice your group. You have group 1, group 2, group 3, group 4, and group 5. And in this slide, we show you an example of outputs. Notice this is for group 3 or G3, and it'll show you your amperage for each wire. In this slide, we show you a basic multiplex system layout. Next, we're going to show you how to access your multifunctional display on the version 2 of Van Hool coaches. First, the buttons underneath your dash. If you push the first display button for 5 seconds, it will display your gauges, air pressure, oil pressure, trans temp, and turbo pressure. If you was to hold the display button and push the door button for 5 seconds, you'll be able to pull out any kind of error codes you may have inside the system. For example, error code No1A6. To erase memory codes, turn your master switch on, press and hold the display button, and turn the ignition switch on and hold for 2 seconds. And that will erase your memory codes. In this slide, we show you how to check your multifunction display selection for version 3. First, push your display button for 5 seconds. Now, if you push the second button, I can test exterior and interior lighting error detection. I can see the test exterior lighting, test interior lighting, read errors, and erase errors. Next, if I was to hit the third button, I could get my temperature readings and adjust my temperature setting. Once I'm in that menu, I can again do my temp readings for interior and exterior, interior temp settings. I can do engine running simulation, HVAC test, and override. If I was to push my fourth button, I can simulation programs and version language. I can go into simulate engine running, simulate the coaches moving at 3 kilometers. I can see my program number and program version for the Kiva system, and I can also do my language selection. If I was to push the fourth button, I can do my garage test, where I can see engine oil pressure, coolant level, transmission temperature, and turbo pressure. And this is how I would go through the system. And this is going to conclude our training session on the Multiplex Training Part 2, Testing the System. For questions regarding this webcast, please contact ABC's Technical Service Department at 877-427-7278. Listen for the prompts for Coach Technical Support and select the appropriate option. Support is available at this number 24/7.